Hello friends, welcome to my channel. In this video, now I am going to explain about the most important reagent that is in DMSO. So dimethyl sulfoxide, that is the oxidizing agents, right? So why we are using that DMSO oxidizing agents? So here we are reducing the alcohol, primary alcohols to aldehydes and secondary alcohols to ketones. So you will get some doubt on this DMSO reagents. So why only for this reagents having this much of reactions? Because I had a discussion about this lecture 1 and lecture 2, that is also belongs to the DMSO reagent, and this lecture also it belongs to the DMSO reagent. So why this much of reactions are required to do the same process as usual? Here also we are using primary alcohols to aldehydes, secondary alcohols to aldehydes. So this much of reactions, why it is required? Because in previous reactions will having some drawbacks, right? So whether it is required more temperature or will get low yield, or it is the time taken process, at that time they are developing the process by using different reagents. So in previous reactions you can see we are using different reagents, and now you can see here we are using different reagents. While using different reagents will get some reduction on this time cycles, or will get more yield, or will get more purity on that. So that is the reason only the people are changing this reactions. You can see here year wise itself. So they are developing the process, we are using DMSO. So here we are using DMS, dimethyl sulfide, and NCS is nothing but N-chlorosuccinamide and the base. So the main process of this reaction as well, primary alcohols too will get aldehydes, and secondary alcohols too will get ketones, right? Tertiary alcohols will not react here. So you can see in this example I given, well, here we have a primary alcohols. Obviously we can get the reaction product is obviously aldehydes, right? Because it is a primary alcohols, you will get aldehydes. So what is that exactly mechanism happening here? We'll go to the mechanism, what is that exactly happening here, so that you can understand better. So in any reactions you should must know that this reaction mechanisms. So here I am going to explain about this mechanism, what is that exactly happening in this mechanism. If you see here what we are using, first we are using a DMS, dimethyl sulfide, and one more is N-chlorosuccinamide. So this is for what? N-chlorosuccinamide. Here we have a lone pair of electrons. This will migrate on this chlorine center, and this bond is migrated towards the nitrogen atom. Then we can get, so here we have a, what is that? Yes, positive charge, and it is chlorine. So we'll get here nitrogen minus, right? So this nitrogen minus is attack on the sulfur center, this chlorine will leave. So we'll get that substrate is here nitrogen, here we have a sulfur, and it is treated with, you will take here secondary alcohols. So here we have a oxygen containing a lone pair of electrons. This lone pair of electrons is migrated toward the sulfur center, and this bond is migrated towards the nitrogen. Then we can get the compound is, once you know one reactions all are similar, you can identify sulfur, and here we have a CH3, and you can write here H. So again we are using triethylamine, it is the base. Obviously you can say that you are know that very well about this base. What is that base will do? It will obviously take the protons, right? So here it will take the proton, will get negative charge. Here we have a hydrogen. See careful, what is that? This nucleophile is take the protons from here, and this bond is migrated here. So here we have a positive charge, right? This bond will leave here. So finally we'll get R dash, and next one is, as usual, we'll get DMS. So this is for what? ketones. This is the reaction of Korey Kim oxidation reaction, and we'll move to one more reaction, that is in Swern oxidation. This is the most important reactions. In every times they are asking this question regarding this Swern oxidation. So in this DMSO, Swern oxidation is important. So Swern oxidation reaction, I think, did you observe that same in any mechanism regarding this DMSO, it is also same common reaction mechanism when you observe all the reactions. So here reagent, what is the reagent in Swern oxidation we are using? Reagent is TFA, trifluoroacetic acid, DMSO, dimethyl sulfoxide, as usual base triethylamine, right? So it is also using for primary alcohols to aldehydes and secondary alcohols to ketones. If you see the mechanism, so here I am going to explain about the mechanism right now. TFA, trifluoroacetic acid, this is for what? Trifluoroacetic acid. Trifluoroacetic acid is treated with a DMSO. You can write DMSO like that. So this nucleophile is attack on this carbonyl center and this bond will migrate here. So you will get that product is substrate is, what is that? So this total bond will leave, right? So here yes, and here O, and C double bond O, CF3, right? So it is treated with secondary alcohols. Here I am going to take secondary alcohols, see oxygen containing a lone pair of electrons. So this lone pair of electrons is migrated towards this sulfur atom. This total bond will leave. So we'll get as usual same, what is that? R dash O, yes, right? Here we have hydrogen. So it is treated with a base. So you'll know that it will take the proton, you will get negative charge. Here we have a hydrogen. This hydrogen will take here, this bond is migrated here, and this bond will leave. So again you will get same product, that is in ketones, that DMS. But what happened to this reaction mechanism exactly? See here, this is not satisfied. This reaction is not satisfied. So again they are implementing another reagent. See here, what is the reagent they are using? So they are introduced one more reagent because they are doing a developmental activity. So after developing, they are using COCl taken twice and DMSO and base. So they are introduced this reaction, these reagents. If you see the mechanism, so Cl, here we have a Cl, C double bond O, Cl, it is treated with a DMSO. So you can write DMSO, right? This electronegativity atom is migrated towards the electron deficient place, and this bond is migrated here, and chlorine will leave. Alright, directly if we see, so here we have a sulfur, and here O, C double bond O, C double bond O, Cl. If you see this reaction, what is that? How the electrons are moving, most important. This chlorine, see careful, this chlorine will attack on this place, sulfur place. This bond will leave here, and here this bond will leave. So totally what are the leaving groups here? You can see here we'll get that compound is this is the most important compound in competitive exams. The people are going to ask what is that intermediate will get or like that. So we will get CO2 and CO. So this is for what? So it is important. So in this one we are treating with, so here I took this one. It is treated with alcohols as usually. So this lone pair of electrons is migrated towards this sulfur center and this chlorine will leave. So we'll get R, R dash, O, S. You can write here hydrogen. After that base, base will take the proton. Here you will get negative charge. Here we have a hydrogen. This hydrogen will take place. This bond is migrated here. This bond is migrated here. You will get the ketones and DMS. See, in these reactions we are using base. So without base, what is the product we get? You can see here I will write without base. Same in this product, in this intermediate I will write again. Here we have a O, here S, S, S. So without base, which product will get here? We have a chlorine negative, right? So this chlorine negative will attack on this carbon center. This bond is move here. Then we can get this is the SN2 pathway reaction. This is for what? Our product. So this is the without base. Without base, this product will get. With using base, we'll get aldehydes as well as ketones. If it is using primary alcohols, then we can get aldehydes. If you are using secondary alcohols, we'll get ketones. And if you see one more reactions, what is that? Example. Here I will give one reactions to you. 5-membered ring, alcohols, COCl2, DMSO, DCM, solvent, and here base. You will get A product, COCl2, DMSO, DCM. So without base, with base and without base, what will get? You will get B product. So first I am writing the A product, that is with using base. So write COCl2. Again same reaction mechanism. COCl2 is treated with a DMSO, O minus. So here we have a positive charge. This nucleophile is attack an electron deficient place. So chlorine will leave. You can get ME, yes, ME, and next to C double bond. Here you will get O. Next C double bond O, C double bond O, Cl, right? So if you see in this reaction, this chlorine will leave attack on this carbon center. This bond is migrated here, this bond is migrated here. Then you can get, here we have a sulfur, right? This is a sulfur. Me positive charge. Here we have a chlorine. So this chlorine is attack on, here we have a 5-membered ring. Lone pair of electrons is migrated toward this sulfur center, chlorine will leave. So you can get here you have a CH2 and here O, sulfur, right? You can write hydrogen here. So again base. What will do the base? It will take the proton here, negative charge. Here we have a hydrogen. So this will take that hydrogen here. This bond will leave. Oh, not it will. Here hydrogen will take, right? So you can see here. I will write very clear. Don't be confused. Here we have a O, S, CH2, H. Here we have a hydrogen, right? So when it is treated with a base, so it will take the proton here, negative charge. This negative charge will attack on this proton. So this bond is migrated here. So this bond is migrated here. Finally, you will get the product is aldehyde containing group, right? And this one is with using base, right? Base we are used here, and without base we can see here total everything is as usual. So here chlorine, C double bond O, C double bond O, Cl is treated with O minus. First charge, this nucleophile is attacked on here, chlorine will leave, so that you can get yes positive charge here O, C double bond O, C double bond O, Cl. So this chlorine will attack on this carbon, and this bond is migrated and this bond is migrated. You can get sulfur here, Cl. So positive charge. In this one, I can write here treated with 5-membered ring. This new lone pair of electrons is migrated toward the sulfur and this bond is migrated here. Then you can get here CH2, here O, here we have a sulfur positive charge. So here we are not using base, right? So this chlorine minus ion, it is attack on SN2 pathway. So this bond will leave. So you will get chlorine, right? This is for what? Our product. It should follow the SN2 mechanism. So this reaction is called Swern oxidation reaction. So DMSO reagent is completed. This total reagent is lecture 1 and as usual lecture 2, and this lecture 3 is belongs to the DMSO reagent. So this is for what? Today lecture. Thanks for watching.